Alright guys, so this last part of lesson 8.3 we're going to talk about word problems. So example 4 says that the suspension cables between two towers of the Mackinac Bridge in Michigan form a parabola that can be modeled by that equation where x and y are measured in feet. What is the height of the cable above the water at its lowest point? So let's highlight a few things. So maybe you know this bridge. I've had some students in the past who have, but that x-axis represents the water, okay? And then, so this is the water level, and the y-axis represents the height, and that's both are in terms of feet. So obviously we see our equation, and I'm sure these are even some rounded values. It's not super friendly, but it's a real life scenario. The height of the cable above the water. So maybe they're trying to figure out, can a bridge, or can a certain sailboat or cruise ship or something, whatever, not cruise ship, but like, you know, tour guide, anything like that. What's the height that can fit underneath there? So they want to know what is the height of the cable above the water at its lowest point. Okay, now obviously there's the road that it would have to pass through as well, but the height of that cable at its lowest point is going to be right there. So that's another word for vertex. So they just want us to find the vertex. So I actually already did that. Step 1, I found my axis of symmetry. Step 2, subbed it in to find the vertex. So we find that this point is actually 1,887.76. So it's that many feet over. And the actual answer to the question is that it's 202.77 feet above the water. So the cable at its lowest point is 202.77 feet above the water. Okay, and I'm sure the road is similar to that as well. All right, now let's go to the next page. That one I did for you because of the numbers, and we're going to skip letter B because it's very similar, but let's work through example 5 here. So we're launching water balloons. A group of friends is launching water balloons, and there's the function representing the height in feet of the first water balloon. Okay, so I'm actually going to write this in right here. I've already read the problem, but so I'm just going to help us piece it together. If you want to pause it and read it yourself right now, we're going to talk through it in pieces. All right, so this graph is going to represent that function. This is our first launch, okay, the first water balloon launch. Now this is going to be the second water balloon launch, as they have marked here, and it tells us that the height of the second water balloon, t seconds after it's launched, is shown in the graph. So t is our seconds, and this is our height in feet. Okay, the question is, which water balloon goes higher? So we can kind of approximate that our maximum value here. If I look at how the graph is working, it's counting by 25, so this would be 125. Oops, we don't want the highlighter there, sorry. This is going to be 125. So this point is just a little above 125, maybe 130-ish, somewhere around there, okay? So let's go ahead. We need to graph this first launch and figure out, does it have a height that's more than 130? Basically find the vertex is really what we need to do. So step 1, we know axis of symmetry. Okay, so I'm going to go ahead and it's x equals negative b over 2a. So that's negative 80 over 2 times negative 16. And if I do 80 divided by 36, because my negatives cancel out, I'm going to go ahead and get divided by 32, sorry. 80 divided by 32, I'm going to get 2.5. Okay, so I have an axis of symmetry at 2.5. And again, these are my same units, seconds, and my height in feet. All right, so now I'm going to go ahead and find the vertex. So this is going to be negative 16 times 2.5 squared plus 80 times 2.5 plus 5. All right, so 2.5 squared is going to give me 6.25. I'm going to multiply that by negative 16. And this first number is going to be negative 100. Okay? All right, then 2.80 times 2.5 is going to give me 200. I add 5. So negative 100 plus 200 is 100. And then 100 plus 5 is 105. Okay, so that means my vertex is the point 2.5, 105, which really means that 2.5 seconds, we're going to be 105 feet in the air. So I'm going to count the same units, 25, 50, 75, 100. And then this is 125, so approximating it, it's going to be about here. The graphing element isn't that critical. I know my y-intercept is 5, so again, it's really low. Flip that over. That's because they're not launching it from the ground, probably 5 feet in the air. But it's going to go something like this and like this. But all I really care about, and the only part that really applies here, is anything that's in the first quadrant, because then it lands on the ground. So the arrows aren't even really that accurate in this case. I shouldn't have drawn those. But anyways, my vertex here is 2.5, 105, and labeling that's at 2.5 seconds, my water balloon is about 105 feet in the air. For this one, it appears that a little bit later than 2.5 seconds, my water balloon is definitely higher than 105 feet. That would be there. So the answer to the question is, which water balloon went higher? And it is the second water balloon, the second launch. Okay. All right, now if I scroll down, which balloon is in the air longer? To do that, I need to go ahead and find my x-intercepts. Okay, so I would want to figure out what this point is right here and what this point is right here and compare those. Okay, so I would want to go ahead and factor this problem. I'm going to skip over that part for right now, but you could either factor out a GCF and see if it's factorable, or use a quadratic formula. Okay, that's what you would do if they want to know which one is in the air longer. We did that a lot with some past problems. And then which one reaches its maximum height faster? Well, guess what? We can tell that right away. It seems like this one reaches its maximum height. We know it, 2.5. This one appears to take longer because 2.5 would be just a little bit further left and it looks higher. So the one that reaches its height faster is launch 1. Okay. As for this part, I'm sorry I'm skipping over it. I just know that the numbers aren't going to work out too nicely. Potentially, there's a potential for that. And so we've done quadratic formula, but if you have questions, I'm happy to do it. All right, one little bit left. I'd like to set up, or at least talk you through the first one. There's only 2 homework problems that are word problems. This is one of them. It says the function shown represents the height in feet of a firework t seconds after it is launched. The firework explodes at its highest point. Okay, so this is seconds again. This is height in feet. They say that the firework goes up and comes down. So it's going to go up and come down. There's no initial value, so that actually, notice there's no plus c, so my y-intercept is just 0, 0. And that's the scenario, okay? And it explodes at its highest point. That's wherever it explodes. All right, part A, when does the firework explode? So what do they really want you to find? That topmost maximum point, which is our vertex. You're going to do the axis of symmetry and then apply that, sub that in for your vertex. And then what height does that firework explode? Well, our vertex, the x-coordinate tells us the seconds, the y-coordinate tells us the feet in the air. So really, for the second part, they want to know how high is it? What are your feet in the air? Okay? Then there's one more word problem, but I'm not going to set it up. I think I want you to give that a try on your own. It's only 2, so give them a good go at it, and see me with any questions. Thanks, guys. Bye-bye.